everybody. We're going to be looking at how to produce more realism, specifically with curves for your chords or for little snaky worm things or anything like that with geometry nodes. So it'll be basically like an pseudo introductory course to geometry nodes. We're just going to open up this panel here, and we're going to, first of all, we have to add something to modify. So let's add in 2 cubes. The reason I'm adding cubes in is just because I want to have something, because it's going to look like a power cord. So I want something that looks like it's plugged in somewhere, just as a reference. So I'm just going to add 2 cubes. I'm going to this little bit here. Okay, so now we're going to add a curve. You go into add, and you go down to curve, Bezier curve. So I'm going to scale the curve to 2 meters. And since the scale is disproportionate now, so it's really off key, I'm going to just bake that in or apply scale. I'm going to make the boxes a little bigger too. And the boxes they're optional. I mean, it helps to have some reference for the ends. So we're going to go to the first view, down Y, you press number pad 1, tab, G. This is really just editing curves. I'm going to edit the curve. You can use the regular modifiers like scale and move on your curve handles. And this curve only has 2 handles. All the base curves that you add, or at least the base curve you add in Blender, has 2 handles to start with. So I'm just doing a little bit of basic modification to get the curve in generally the position I would like it to be in to start with. Okay, so I'm going to show you a couple of options for making a chord. These are not geometry node based options, but they are quick options, and it gives you a reference as to what geometry nodes can do compared to the regular way. So you go in your properties drop down here, and there'll be a curve option. You select the curve option, you go to geometry, and then you go to object. Oh, no, excuse me, round. So your depth for your bevel, for your round, you can change that. I'm going to make it 1 millimeter. It's not accurate, and I'll tell you why. So this is one, first of all, this is one way you can do this. It's a very simple way. It is procedurally generated. You can see that there is geometry here, and you can change the resolution. You can also change the render resolution. It does cap out at 64. When you change the resolution, if you're going to add in more, we're just going to subdivide our curve, and it adds in more actual detail. I'll show that again, except close up. So the number of polygons changed for the closer spaced handles. So it is procedurally generated. I'm just going to delete this. That's one way to do it. Another way to do it would be to, we're just going to remove this so that there's no bevel on it anymore. 0. We're going to, I'm just going to center the cursor. Select cursor to world origin. I'm going to add in another curve, circle, and zoom in on the circle, or center the view on the circle. So there's another way of doing this. You select your original spline or your original Bezier curve, and go to, under geometry, go to object instead. And now we can select one of the objects. The strange thing though is that that's obviously not as large as the circle. So one of the reasons why it was not accurate before is because, actually the reason why it was not accurate before, and it's making this is also an inaccuracy, is because if you look at the individual handles, there's a setting for them called radius. You can change the radius, and when you scale the curve, I scaled it outside of object mode. I mean, I scaled it in object mode. It was not in edit mode. When you scale it in edit mode, it doesn't change the size of the radius for the curve. But when you scale it inside of edit mode, or object mode rather, the radius for the curve changes. So you set that all down. Again, it's procedurally generated. There's a lot more detail here just because the curve here has a fair amount of detail. And if you went to the curve properties for the profile, you can change how detailed it is. So curves have a lot of potential, but we want to do something more realistic than that with this particular curve. So we have to go about building a geometry nodes for it. Geometry node tree rather for this. So select the original curve, remove the geometry for it, just select the round with a 0 setting, 0 depth, and we're going to add a modifier and geometry nodes. So this is the name for the geometry nodes modifier in the tree. So I'm just going to change this to core details. This one is the name of the geometry nodes node tree. So if you import your geometry nodes node anywhere into other files, you're going to want to have this a recognizable name so that you know easily know which node you want to import. So I'm going to just call it power chord. Details. And it doesn't really matter. You can call it whatever you want. Save this. Save as. Working. Okay. So we have a node. Now we're going to go into this window here. Select Geometry Nodes Editor. This is what we're faced with when we open this window up. So in this window, you have a output and an input. This is what samples the geometry you applied the modifier to, and the output is the resulted effect, the result effect. So we're going to demonstrate what's going on here. We're going to just say curve to mesh. Down further, curve, mesh to curve. I want curve to mesh. Okay, I go add curve, curve to mesh. Okay, now we're going to add curve to points, mesh to points, excuse me. Mesh to points. So in the wireframe, we can see this. The points have a scale. So if we went to this one here, you could see the points have a scale as well. We're going to scale the radius of the points down a little bit. That's too far. All right, so we can already see a couple of things going on here. When it's sampled the curve to a mesh, it's actually extrapolated. It's not linear from the end to the start to the end of the curve. We can actually go into the curve and change this. So it's obviously, it's not a linear curve. It's not a linear sample. It's definitely taking into account the increased necessity for geometry at the extreme bends of the curve. Anyway, that's the first point. So now what we're going to do is we're going to try to offset these because we're trying to introduce like little wiggles or twists and different things in the chord to make it look a little more realistic. With minimal effort, so that this is a procedural effect you can add to a chord. You can model the chord, and then you can take the chord and you can texture it and do all kinds of other things with it. So to do that, we're going to use a set position. No. Set position. Yeah, set position. There you are. So we're going to use a set position. We're going to put it after the mesh to points. The mesh to points we don't use in this particular node setup, but it's just as a demonstration of how this looks. visual demonstration of what's going on. So we're going to then take a value. No, first of all, we're going to demonstrate. Okay, so offset. You can set position for points. The set position, what it does is it sets the absolute position. So if you want to set it to, this is a vector base. So if you want to set it to 3 numbers, like if you want it on the positive 2, positive 3, negatives, rather positive 2z, negative xz, negative x, and negative y2, or something like that. You set the absolute positions and global coordinates. Offset will offset the position based off of its current position. So we're just going to demonstrate that. You can offset it, but it offsets all of the points. And what this is doing is it's sampling every single point and offsetting it, but it has the same value for every point it wants to offset. So if you offset it along, let's say, the x, it's going to offset every single point along the x value. So it's not sampling it right to the center of the global coordinates. But we don't want to sample it, or we don't want to offset it by exactly the same amount each time. What we want to do is have different amounts to make it more, to make it dynamic, to make it give it detail. So search noise texture. And now if we plug the noise texture's color into the offset, we get sort of what we're looking for. But you'll notice that it's, first of all, it's, for whatever reason, it's always in the positive quadrant of the cardinal system. So it's in the positive x, positive y, and positive z locations. The reason that's the case is because the output from color is a 0 to 1 grade for every single channel in the color spectrum. There's no negatives. So it's always going to move, plus it's moving it by the same amount. So what we need to do first is we could add a map node. Well, actually, what we need to do is separate the channels. So the color output differs from the factor output. The factor output only has a single channel. The color output has 3 channels, RGB, and the noise texture actually outputs 3 color channels that are distinctly different from each other. There are like 3 factors that are slightly different, but mapped to specific colors. So we're going to separate that. RGB. Separate RGB. And then we're going to combine XYZ because we want a vector output from the result. And we're just going to plug these together. It hasn't changed anything significant yet, but that's because essentially Blender extrapolates a color channel into a vector automatically. So what we need to do is we need to actually map these so that they're centered on the spline. So we're going to change the range using a map range node. And we're going to just stick it in there. And the from and to, that's correct or accurate, but we want to map it to 0.5. We're just moving the range to negative 0.5. So now we've done this with the x-axis, and you'll notice that it's actually mapped it so that it's on top of the spline. You can see this. We'll go down the y-axis here. The z is still influencing. So now we're going to do the same with all the other ones. And it's just a matter of copying this or duplicating it like so. So now we have our point cloud laying right on top of our spline, which is great. It's exactly what we want. So now that's done. We're going to take the mesh to points. We're just going to remove it because we don't need it. Set position, curve to mesh. And now we have a curve that connects all these points. And we'll notice that you can change this. It'll change a lot of things on the curve. It's really cool. Okay, so let's take the curve to mesh and put it on the other side. Put it over here. Now what's happening is it's sampling the 2 points we have. We only have 2 points on this curve. Actually, we have more than 2 points. We have 3. Let's see. We have 3 points. 1, 2, 3. 3 control handles, but they're considered points for the reference for the sake of this particular application. So what we want to do is add more. So we're going to resample the curve to have more points. This is great because we can change the number of points and it changes the resolution of the curve. I want to have access to this though outside of the geometry nodes tree. So I'm going to take this node, this output here from the group input, which is confusing, plug it into the count for resample. And what we have now is we have a count in our modifier, in the modifier stack for geometry nodes where you can actually change the resolution of the curve. So I'm just going to rename that so I can remember what it is. Curve resolution. Very simple. Okay, so it's still pointy though. So since it's a curve now, since it's a curve now, we could just crank this up until it's smooth, but we don't really want that many samples. We don't need that many. It gives us more control if we have fewer samples. Let's set it to 15. So what we're going to need to do is we're going to need to change the spline type, because right now it's set to poly by default, I believe. Set spline type. Another way to access this is add node curve set spline type, and we're going to also we're going to put it after the set position. Does it matter? I don't think it does. We'll find out. Set handle type. So we want to change the handle of the curve to something that's smooth. So now we have a curve that's actually smooth. And we'll change the detail here. And it changes the curve a little bit. Set it to 20 probably. So we're at this stage now, and I'm wondering if it changes anything if I set this afterwards. Doesn't look like it. Leave it there for now. Okay, a couple of other things I want to have access to are the scale of the noise itself. And we're going to call that one scale, offset noise scale, because this is going to be important. Okay, this is the basic parameter done. And we're going to now go to the next part. We need to gate the values for. Oh, let's select these. We're going to put these inside of their own frame because they're now basically the way I want them. I'm going to select just these and add, excuse me, node, join a new frame. I'm going to name this frame something. Node label just offset noise is fine, I suppose. Now we have these 3 lines here for the offset itself. But we don't want the offset. We want to be able to control how much offset's going on here because there's no way to control it at the moment. So we're just going to add in a math node. And it's going to be a multiply node. Multiply. So if we duplicate this for each channel, and then we're going to add a value node, just value, and plug it into those 3 on the other side. So you're multiplying the what comes out of map range by whatever's in the value setting here. So now we have control of the amplitude of the the effect itself. So I'm going to right click, shift, drag to merge those noodles or node lines together. I'm also going to want control of this particular variable as well. So I'm going to leave that here for future reference. And this one is going to be called group. It's going to be called offset amplitude. Offset amplitude. So we now have control of offset amplitude. Great. The tricky part now is that we don't have, looking at this right now, you can tell that the point is not where the end is offset to. So this is problematic for a power cable because you want your cables to go into specific, very specific locations. You want to go into a plug or some other particle, some other thing. So I need to be able to control exactly where the power cable ends are going to end up. To do that, we need to somehow use this gate here, and I'm going to rename this to gate. I'm going to join it rather in a new frame. I'm going to call the new frame gate. Because essentially that's what we've done. We've used these multiply nodes to create a gate. Because anything multiplied by 0 is 0, and anything multiplied by 1 is whatever it was before. So it's acting exactly like a gate. So now we need to somehow figure out how to map a range to map onto this gate. And I find it very helpful. It's almost impossible to design this kind of node without the viewer node. It shows you exactly what numbers are coming out of what outputs. So we're going to plug the output into value, and then geometry gets plugged into the output geometry. So this would be the geometry that we're trying to use. So now the way you look at this output is you go over here and you select, I'll use the other menu here. You go over here and select spreadsheet. And in spreadsheet, you need to be able to select not evaluated, but viewer node. So under viewer node, there's several viewer nodes, and it assesses exactly what's going into viewer based off of the output. So right now it's a Bezier spline. So under curve, it would be control points. So now we see exactly what's happening. This is the output of multiply here into the value. So now we need a curve we need a fall off that represents the curve itself. So we have something called that, something for that rather. It's spline parameter. And spline parameter, if we just plug it into factor, we can see that there's actually a fall off now. It goes from 0 to 1, which is good because we can use this. We can manipulate this with math to do exactly what we need it to do. One last thing, for this particular video, we're going to add in something so we can actually see the profile of this curve. So we're going to add in object info, because you would think, let's say we plug this in, so it's not a mesh, it's actually outputting a curve. You would think that, naturally you'd think that you could just go into the properties panel here and select curve, and then since it's outputting a curve, you would think, oh, I'm just going to go down here and change this so it's 1 millimeter. Let's change it so we can see it. But that's not doing what we thought it would do. It's doing something very strange. You notice that there's actually some error messages in the geometry nodes editor, and they say that it's the wrong type. Input geometry as unsupported type, mesh. So now what's happening is Blender's passing this, this takes precedent over anything in geometry nodes. It's passing this thing that it's turned into an actual mesh object. It's procedural. You can still change the points to move the mesh around, but it's turning it into a mesh for the sake of geometry nodes, the way geometry nodes sees it. So this doesn't work. So what we're going to do instead is we need to make it a mesh in geometry nodes. So we're going to just put this back on, curve to mesh. And we have this object info. This object info will allow us to sample information from any object in the scene. And we're going to select profile. We're going to take the geometry output from this and plug it into profile curve. Now we can select one of these curves, and they're both named the same thing. So I'm going to just rename it. Outliner, rename this to profile, and we're going to rename this to chord curve. So we can take this and we can, we know which one's the profile now, and it actually will make the profile and it outputs a mesh. So we can see the mesh here itself. We can change the resolution of the mesh by changing the count. And we can do the same thing with the curve itself. So let's take a resample mesh. We'll move it over here and we will stick it between these two here. So now we can actually resample the detail of the actual profile curve to get more resolution if we need it, which we don't. Probably higher than that. So I want control of selecting the profile object in my output here. So now we have an object. We're just going to rename that to something. Object here. So this would be curve, profile curve, and we're also going to want control of the resolution of the curve. So we're just going to rename, we're going to have this one here, and we're going to call this one profile resolution. All right. Well, that's gotten us to this point. I'm going to move this up here and this one up here as well, just for the sake of it. And that has gotten us to this point so far. Feel free to clean up these lines because they will get more complicated in the future. I'm just going to clean up some of these lines a little bit so they're easier to read. And in the next video, we'll work on getting those fades to work, because it's kind of important for moving forward with this, that we definitely need those fades to work correctly. Otherwise, this is not going to work very well. It's going to be unusable as a power chord generator, as it were. So I will see you in that video.